We've had an absolutely fantastic Ostmine conference. Over 1,200 delegates. We've had a world-class lineup of speakers and exhibitors who were part of this event. And I look forward to seeing you in 2021 in Perth.
Good afternoon, and welcome to this session where we'll be taking you through Uptake's AI and data science solutions for the mining industry, in particular focusing on how our software helps our customers optimize their maintenance strategies and predict failures before they occur. So over the next 20 minutes, we'll briefly introduce Uptake, we'll talk through our industrial content and give you some overviews of our products, and then we'll show you a demo of our software, and then we'll finish by taking you through some impact stories and some customer case studies. My name is Tom Fisher, and I will manage the Asia-Pac business for Uptake. And later in this presentation, you'll meet Alvaro Eliso, who leads our sales engineering function for the APAC region. So let's introduce the topic for this session. $1 trillion a year is the number that ARC estimate of the impact of unplanned downtime across processing industries. And it's this number that every utility, oil and gas company, every transport business or heavy equipment dealer that we work with, or especially every mining company that are working with us at the moment, are doing their best to minimize. And even the most advanced, well-run operations still experience unplanned downtime. Now, aside from increasing the maintenance of key processing equipment in order to maximize asset health, of course, this would be a costly outcome and would likely result in reduced productivity and increased maintenance costs. Mining companies we work with are all trying to digest the information that their machines are generating in order to prevent unplanned downtime. But it's not that simple. And a problem that we hear time and time again is that maintenance and asset management professionals across the industrial world, but particularly in mining companies, are faced with an absolute tsunami of data. It's just difficult to process, and it's difficult to extract the hypothetical needle within the haystack that will inform them of their potential asset failures. And so this is where Uptake comes in. Globally, there's data scientists working right now on a myriad of different problems for industrial companies, but we've been laser focused on solving just two things. One, how to best run a maintenance organization, both optimized for asset health and financial terms. And then secondly, how to predict failures before they occur. And we've been doing this through generating cross-industry expertise, working across the industrial world over the last 6 years, and developing our data science models and industrial analytics software in concert with our customers. And so the result of now monitoring more than 1.3 million machines comprising 2.4 billion hours of learning is that we've adopted an approach where we've now patented our approach with 33 patents and another 40 pending. And this is all in the pursuit of actionable insights that mitigate risk, optimize maintenance strategies, inform and improve asset performance, and enhance safety, whilst reducing costs for our customers. And before I move on to showing you our products and exactly how we generate that value, I just wanted to touch on a key piece of content that's really a valuable differentiator for Uptake. So the Asset Strategy Library, or the ASL as we call it, is now more than 40 years old, and it's constantly improving over time. And it covers more than 800 different asset types across the industrial world, and it captures practically every asset and sub-assembly that's present on a modern-day mine site. So this library describes about 58,000 different ways in which those assets fail. And so we know how assets perform from the use of this database, but more importantly, how they fail. And so we know what to look for before something breaks. When we engage with our customers, we know what data to ask for that will give us an early indication of a particular fault on an asset that they want us to work on. And so in addition to these failure modes, there's more than 5,000 different preventative maintenance tasks that when you use those tasks combined with an additional maintenance strategy, you can get a 20% reduction in maintenance cost, and you can improve reliability by up to 15%. And the Asset Strategy Library is a key component on which all of our products are developed. And so moving into a brief overview of our products before we show a demo. What I like to do is describe to you our two software applications and show you how they fit on the operational excellence maturity curve. So the first one is Uptake Compass. And this has a financial maintenance optimization component. You can see that on the bottom of this slide. That helps, and it's then got another component that helps optimize maintenance strategies tactically for increased component survivability, reduce parts and labor costs, or improve asset reliability depending on what you're trying to solve for. And Compass, importantly, can be used on both connected and unconnected assets, as it doesn't need IoT or sensor data to produce an outcome or to prevent a failure. And we find that this tool is a really key component of a mining company's data-driven maintenance strategy, and it can be used whether they're early in their adoption of a condition-based maintenance practice or if they're very mature in this space and are seeking the best-in-class data-driven optimization tools. And so you'll see on this slide, it's often adopted early on in the piece where you might be at a calendar-based or usage-based approach to maintenance, but also it can drive a lot of value for people that are working in a predictive or even prescriptive maintenance operation. Uptake Radar is our advanced analytics package. And so with Radar, you get pre-built and pre-configured data science models that will predict common failures on common asset models before they occur, leveraging sensor data from your machines, as well as fluid sample information, fault codes, and even historical work order data to help us run some supervised machine learning. So now, instead of showing you more slides on what our products look like, we thought it would be best to show you them in action. So I'll hand over now to my colleague, Alvaro Alesso, and he'll take us through both Compass and Radar.
Thanks, Tom, and hi, everybody. My name is Alvaro Alesso. I'm a sales engineering manager for Uptake. And what we're looking right now is the first screen of Uptake Compass. It's a place, an environment where we can extract operation and maintenance insights based on disparate data sources. In this case, we're looking at work order data that has been previously cleaned using our natural language processing algorithm, NLP, together with production data, but it could be inventory data for which we do things like, for example, survival curves and component survival analysis, could be transactional data from where we would do cost analysis as well. And in this case, we're looking at dynamic dashboards that have been configured following a series of metrics that this team found important. Downtime, reliability, and the effect on cost, plant maintenance, and material consumption. So essentially what I can do here is, go to whatever metric matters to me or my team or the relevant conversation that I'm having at the moment, looking at, for example, in this case, I'm going to look at corrective maintenance tasks for, let's say, high criticality assets. Here I can even dig a little deeper and instead of looking at planned corrective, meaning activities that required action but not immediate action, I want to actually look at the urgencies, right? And within those urgencies, I want to look at those activities that demanded service, a third party coming in, and I can, do another click, and quickly I'm recognizing assets that had high cost. Let's say this motor stands out, and I can see that this motor had excessive costs associated with it, especially around equipment being down in mid 2016. So I can actually go to the raw data tables that make those costs up and understand what were the main activities that really drove that at that time. And here I have two options. I can either make use of Compass main strategy powered by the asset strategy library, Uptake's exclusive content, or I can actually deploy a pre-trained predictive model that looks at components of that motor. We do that in a different environment called Radar. And let's jump on that. This is Radar. In Radar, I'm going to have high-level overview, specifically centered around what we call insights, essentially predictive model output, new bits of information looking into the future that allow me to either prevent catastrophic failure, defer main strategies, especially those that are low value, or even bundle activities and optimize my main strategy. Here I can filter for whatever is important to my operation. I have looked at concentrator, but I can bring a couple of them up and just look at everything that's important to me or my team. Trends, in this case, downtime by plan area over time. I can look at work orders that were issued recently, the ones that have been open and not closed. But what's really interesting is when we get into the insights page and start looking at the insights that have been issued for some of these plan areas in recent time. I'm going to look at, in this case, loss of efficiency due to voltage drops in a precipitator, coolant leaks, and one of the insights that could easily apply to one of these motors is dry bearings alerts. So I'm going to click on that, and this is going to take me to the insights page. Let's open that up, where I can see, in this case, an insight summary, status details, the signals that were relevant to this model triggering. I can see vibration and other signals that were relevant and help inform the model. In this case, we have a long list of insights. This will act as supporting evidence for a condition monitor analyst to maybe generate a download in CSV form, go a bit further and try to get supporting evidence to take action. Recent work orders to provide context around the PMs that were done around this asset, and even provide an environment to keep that knowledge in-house and discuss with my team, what should we do? What can we take? This is a great way to keep that knowledge within your organization. And also in the future, once you have seen a bunch of insights going on for the past year, you can sort them out by comments as a measure of, let's say, popularity of an insight. What's really cool is this is a tool that allows you to track change around these insights, whether you want to disregard it and just train the machine learning algorithm that is powered this insight, or close it. Meaning close it is you will generate the template of a work order data that you can either visualize or send to your CMMS or EAM system. You can also look at the assets, see how many insights you have for each. In this case, we're looking at haul trucks. You can, again, you can filter to whatever is relevant for you and see what are the models, what are the predictive models that are being triggered for different parts of your organization. As we said before, we've just looked at Compass and Radar, two parts of the Uptake suite of products. But yeah, eager to show whoever is interested a bit more detail of the other tools we have available for the market. Thanks.
Okay, Alvaro, thanks very much. That was great. So now to close, we've got two impact stories that we'd like to talk through. So the first one here is from one of the world's largest copper producers whose processing plants comprise a large number of fixed assets. They have primary crushers, SAG mills, pumps, filters, flotation cells, roasters, and so on. And it was important for them to engage with us on all of these assets combined, as the plant's productivity, throughput, and operating costs really depended on the combined performance of all of the processing plant. So what we did is we aggregated all of these data sources across the facility into a single platform, and we provided an asset-centric view of their operations, which was something they hadn't seen before. And then we worked with our data science models to come up with some predictive models on common failure modes, and we leveraged our pre-trained data science models to drive predictive insights and surface those in the application. And as part of this work, these numbers that were verified with the customer, we unlocked $8 million in annual value for them by improving asset reliability, reducing unplanned downtime. We augmented their traditional OEM prescribed preventative maintenance tasks with value prediction insights, and we enabled them with cost optimized maintenance strategies. And a closer look into how we achieved those results. So we matched the data available off their machines with the failure modes that we knew existed from our asset strategy library. And based on the data that this customer had, we could predict 11 different failure modes across their 4 primary assets, as you can see on this slide. And the 4 assets were the rotary cooler, the precipitator, the conveyor belt, and the sag mill. And once we had trained these models, one particular proof point that we saw was that we reduced alerts on their conveyors by 90%, which means that we were able to reduce unnecessary noise for them, and it allowed their technical teams to actually focus on solving real problems rather than getting distracted by spurious fault codes. We provided 40 hours of lead time on calcine cooler leaks, which was a 10x increase over what they had before on their existing alert-based system. And lastly, we increased the amount of lead time to 17 days for advanced warning of electrostatic precipitator issues. And the final case study here is a really powerful one because it pertains to fluid samples. And as you well know, fluid samples are taken all around the world every day on mine sites. But we regularly hear that the analysis of these samples is often inconclusive. And so what we did in concert with this customer was configured a set of 33 different data science models that automated the analysis of those samples. And so our customers can leverage the power of AI to identify issues in their fleet from fuel, oil, and coolant samples, which gave their condition monitoring analysts time to focus on actually creating work orders and attending to real problems rather than needing to double check an ambiguous fluid sample that may or may not be an early indicator of a failure. And another key point is that this customer told us that they simply couldn't manually analyze every single fluid sample. The volume was just too high. And that meant that actual problems were going undiagnosed, and they confirmed that it was leading to some unplanned downtime. And so in this particular example for this customer, they saw a net benefit of $3.7 million in annual value generated just from this project alone. And they realized a 17x ROI, which was a huge benefit to them with near immediate payback. So for every dollar that they spent with Uptake, it was a $17 return back to the business. So if you're keen on learning more, please don't hesitate to download more information from our virtual exhibition space here at IMARC, or you can contact Alvaro or I directly on our email addresses listed on this slide here. And lastly, we're also not only looking to engage with people that might be interested in buying our services, we're also looking to collaborate with others in the industry too. So please reach out if you're interested in partnering with us also. And with that, thanks very much. And we look forward to engaging with you further here at IMARC.
We've had an absolutely fantastic Optimising conference. Over 1,200 delegates. We've had a world-class lineup of speakers and exhibitors who were part of this event. And I look forward to seeing you in 2021 in Perth.